That's right. Looking for that.
Hi.
My teacher.
I'm John Gilmore. This is Hugh Daniel. We work on FreeSwan, which is the Linux implementation of IPsec.
Yes, we know that.
And we're here to talk about opportunistic encryption. So how many folks here are running IPsec now?
How many of those folks are running FreeSwan on IPsec?
Wow.
How many
Thanks, guys.
How many OpenBSD users? So this account for one. Okay.
How many folks running other IPsec?
Well, Yami's the other one we want. How many users?
Oh, they could be running Cisco. I don't care.
No, there's three open sources and then the rest.
Right. So, for the people who are running IPsec, what fraction of your traffic is actually protected by encryption? Just call out a number if one comes to mind.
5%.
5%?
20%.
Okay, well, the goal of opportunistic encryption is to raise that number. And the way we are trying to do it is by reducing the administration overhead of setting up IPsec, secured links. So, in a standard configuration of IPsec, where you have a virtual private network, each link requires doing sysadmin at both ends of the link.
Computer stage 1 has already crashed.
Right? You have to set up keys, move the keys around, test the thing, and then you need a third machine in the middle to actually see that the traffic is really encrypted in the middle, etc. It's a fair bit of work. And the result is you only really do it at places that both you have the time and energy and it really matters. The approach we're taking is to let each node that runs a compatible implementation of IPsec publish a key in the domain name system, and then have the other compatible implementations look for that key before they send a clear text packet. So whether you're using IPsec inside a host or on a router that's protecting a whole network, before it will send a clear text packet out onto the internet, it'll do a domain query to look for a text record in the reverse entries, in the entries in the inaddr domain for that IP address. And if it finds a text record there that identifies itself as an IPsec record, rather than send that packet out, it will negotiate an encrypted session with the guy on the other end. What's in the text record is the IP address of the security gateway and the key, and the public key of the guy on the other side. Now, if you want to send a clear text packet out and you do a lookup and there is no text record, then you just talk in the clear. That's the opportunistic part, is we're looking for opportunities to encrypt. And anytime somebody presents an opportunity, then we'll set up an IP connection and we'll set up an IPsec tunnel, and then all the future packets will be encrypted to that destination. Well, you might think this would have a lot of overhead, but it turns out it's not so bad. In most cases, by the time you are sending a clear text packet to some destination, you've already done at least a forward DNS lookup on it, and probably a reverse one as well. So all that stuff is lying around handy in the cache of your DNS implementation. And you can just do a quick one packet turnaround asking if there's a text record there. So the result of this whole strategy is, instead of having to configure both ends of an IPsec link and test them and everything, you just have to configure each node once, and then it will make links automatically to any other node that's been configured the same way. So we've reduced it from an n squared problem to an n problem if you have n nodes that all want to Yes. What happens when someone spoofs the DNS? Great question. Until the DNS is secured, then what we are protecting against is passive attacks, that is wiretapping. What this means is if no one injects packets, if the role of an intruder is limited to listening on the lines, like what all the current international governments are doing, or is limited to sniffing Ethernet traffic, etc., then this scheme will protect you just fine. If the guy who's after you is mounting an active attack, then he could be spoofing DNS records for you, and you won't notice. Now, there are things we can do in the implementation that alleviate that. And one of those things, it's the same thing SSH does about public keys from the other end. It's you remember the key that you saw last time for that IP address. And if it changes, you warn people. You log a warning. It can't be as obvious as it is for SSH because this is a transparent solution. It could be running on a gateway far from where the user is. So what you're going to get is log file entries that say, that guy's key changed. I wonder if it was intentional.
If you can authenticate the DNS by its front, its key, then you can your token to the server. I think that's the essential part. There's no protocol for you.
Correct, yes. If you can authenticate that key that comes out of the DNS, then that secures the whole protocol against both active and passive attacks. And that's part of the reason that we put these keys in the DNS, because there's an active project to secure the DNS. I put in the initial work to get the very first secure DNS support into the production version of Spine some years back, so that people could put key and signature records into their zone files. Even if you're not running a secure DNS resolver that checks those signatures, we at least have the infrastructure out there. It's been out for more than 4 years now. So your version of Vine probably supports these records now, even if you haven't consciously upgraded to it. How do you deal with dynamic DNS servers and strange IP addresses? Oh, transient IP addresses. Right. Dynamic DNS, well, let's see, if you're changing the data in the DNS, then basically you have to change for every host that's protected, say, behind a gateway that does opportunistic encryption, you need to have a text record in its reverse entry that gives its public key and says, oh, the gateway's over here. If you're doing dynamic DNS, you also will have to move that text record around along with whatever other records you're moving, like the pointer record that gives the host name. For transient addresses, typically people don't connect to a transient address, they connect out from one.
But if you want to do encryption between two transient addresses,
Well, if you're doing, okay. The protocol is asymmetric because one person initiates. If the person initiating can look up the record for the other guy, then at least you know who's on the other end. The guy on the other end actually is in a dialogue in ICE with the initiator. And the initiator can identify himself in that protocol in several different ways. One way is to say, my IP address is this, therefore my key should be this. But there's another way to say, my real domain name is laptop.toad.com or something, and the key for me is over there. And the laptop can prove that it has the private key that matches the public key in the DNS of laptop.toad.com or whatever. So instead of just binding you to an IP address, you can bind yourself to any domain name and prove that binding by having the matching type key. So, any other questions? Oh, yeah.
What about like peer-to-peer type of organizing a master type application and become a way to connect to where a lot of the server connected markets
Yeah, it would be good to encrypt that sort of application. But, well, the interesting part of that is you really don't know who it is you're talking to on the other end. You clearly could do something, whoever referred you to the guy on the other end could also say, and his key is this. And then you could use that to authenticate the connection to it. But otherwise, you have no way to tell who he is anyway. So, you, how's it going? Keep talking.
I was not running this set of tests last. Believe me.
So, yes?
Can't you use the iProtocol discover in-house support IPsec? Is it a feature of the iProtocol?
You could try doing an IKE negotiation to port 500 and see what comes back, but
You'd look like a denial of service attempt to us. Seriously.
Okay, so that's your problem with IKE. Is well, and of course,
No.
the necessary traffic.
well, IKE actually is fast enough. By the time we get a key and we do an IKE connection, we can bring up an IPsec tunnel in well under a second across the net. It's like 3 round trips or something. If you're running 100 millisecond turnarounds, then you're done in half a second. So that's not the problem. IKE has a lot of other problems. It's a way too complicated protocol with too many options and too many different ways to negotiate insecure connections. And ultimately, we're looking to simplify and or replace it. Bruce Schneider actually wrote a great analysis of IKE in which he said, well, I found these 6 obvious things, and so I stopped analyzing there. Once you fix those, I'll come back and reanalyze it. But the main problem with using IKE is you connect to the IKE daemon on the other end, and it says, hi, I'm so-and-so, and here's my key. Well, how do you know that that's really so-and-so? The way we're doing that is by going out of band to somewhere else through the DNS. And the whole strategy here was to use the DNS unsecured, and then automatically, by the time other people have done the work to secure it, then our stuff becomes secure against both active and passive attacks.
Are you going to support storage of keys into X509 certificates in the DNS? And that you can check yourself validity of the key?
Our implementation has a bunch of patches for X509 support. I don't think they currently use the DNS for storage, but no.
LDAP.
But yes, there are actually defined ways to put an X509 key into a DNS record, and we could use those. The problem is the X509 certification hierarchies don't scale. What we were looking for is something that'll work with anybody you connect to anywhere on the internet. And the DNS security stuff was designed to scale that way by basically walking its way up the domain tree to say, oh, you're trying to talk to lap.toad.com, so you'll ask toad.com whether lap is a valid location, okay. Now you want to know about Toad, you'll ask com whether this guy is really Toad.com. Now you wonder about com, you'll ask the root. With X509, if you don't have a certificate, if you don't have a key that shows that that guy's certificate is valid, you're not sure who to ask. You don't know where to go, who's authorized to say that this guy really is the guy he claims to be. So, we've been working on this project for, seems like 4 or 5 years by now. We've gone through 10 releases of the Linux IPsec code, which is at www.freeswan.org. And only in the very last release do we finally have opportunistic encryption limping, I would say. It's not the be-all and end-all, but it does run.
It's what I call play opportunistic. It's just fine for playing with, figuring out how it works.
Right. What we were trying to do in this release is get something that runs and get some operational experience with it. Have people try it out and say, you know, it's kind of hard to keep these keys updated. We need more automation over there. Or the log files are doing this and we're not, you know, it's spitting out way too much stuff here. We can't run this production on our main router, et cetera, et cetera. Figure out all the crazy things that happen when you actually try to run this for production traffic and work those out in the upcoming releases. Yes?
What about retransmitting? Is there any way to say that your studio launch index timestamp or something?
I couldn't quite hear the questions. Can you repeat?
If you snip the package and retransmit it, is it possible there's some timestamp or so let's say it's from the right path?
If someone sniffs a packet and retransmits it, are there timestamps to prevent replay attacks? Yes, at different levels of the protocol. In the IKE protocol, it's pretty well protected against that. In the IPsec, the lower layer protocols, it's very well protected against that. Each packet has a sequence number and it keeps track of which ones have already been seen and throws them away if you send them again. At the DNS level, DNS security protects against that sort of thing, but in the current version, if you're not running DNS security, we're not protecting against replay of old key records, for example.
Which I don't think it's really for that.
But once you have DNS security, then you'll be checking the signature on that record, and that signature will expire after a certain amount of time. And at that point, the record's no longer valid.
That's something you can create all the time?
Yes.
Yeah.
Can you handle opportunistic encryption and the classical VPN and the same configuration?
Yes, though there are a few issues in there that we're discovering as we try to play opportunistic encryption. We're still working those out. Basically, the answer is yes. You can configure a bunch of tunnels to particular places, and then you can say, oh, the default is, rather than the default being just send in clear text, the default can be try to go opportunistic. Ultimately, the way we want this to ship in real products is for there to be an N-way switch that you configure. And the switch will say, run everything in clear text, run everything encrypted, run everything opportunistic, that is, try encrypted. If it doesn't work, run clear text. And then potentially have an exception list that says, oh, in these particular hosts, I really care, those have to stay encrypted, or these particular hosts, they can be in the clear, whatever. But right now, setting up a VPN is a long exercise in configuration frustration.
Numbskulls. Yes. Some idiot took charge in on an XINetD. Now I gotta read it back, show you guys how things work. Who's this idiot? Excuse me?
A security expert.
Well, this is one of the things that's wrong with security experts. Don't take away functionality. Idiots.
So part of the theory here is that by the time this is well enough debugged and enough people are running it, the standard Linux implementations will come with this switch set to opportunistic. That is, encrypt to anybody who has put their key in the DNS, but don't take away functionality for the people who have it. Now, there's an interesting, free software has a bunch of interesting dynamics on society. And I found it in my own life to be a great lever for social change. It gives one person the power to actually move the world in a small way by giving out something that's valuable to many other people. And one of the pieces here of how this works, it's what I call the fax effect. When fax machines were first invented, there wasn't much benefit in having a fax machine, right? If you were the first one on your block to have a fax machine, you never could send or receive any faxes because nobody else had one. The second guy to get a fax machine had one person he could talk to. So he had to have a really high incentive to get that fax machine. Plus they were expensive because they were new, etc. Right? But say, one branch of an office and another branch of an office would have a sufficient incentive, they'd start sending faxes to each other. Eventually, some customer would go, I'm doing a lot of business with you guys, can we just fax it instead of send it? And they go, oh yeah, we have a fax machine, why don't you get one? So the third guy would buy one. And gradually, the more people have them, the more useful they are.
Because this scheme relies on the reverse DNS entries, and for example, in the Java, actually in the normal ISPs can control their own reverse DNS. It's done on a national level. It's basically unused in Java, for example. Since there's some kind of more end-to-end proposal for this, like trust any certificate and just try to find everybody.
Question is, if you can't control your reverse DNS entries, is there some way to do this end-to-end without bothering with those blithering idiots who run your domain name hierarchy? The answer to that is a little bit deeper in the technology than I'm sure I have the right answer for now. Clearly, one end of the connection in IKE can say, my identity is this domain name, forward, and that I control, etc. But I don't think we can do opportunistic doing both ends that way yet. I think there's some security problems with that. Because other ends can claim to be anybody. And what we were using the IP address for was to authenticate. Yes, no.
If you have two machines that both run this, you have two chances of actually getting the link secure, because either one of you, because IP address works, and you negotiate secure link. Only
But you need keying material in both directions.
and the IKE protocol doesn't do that for you.
The IKE protocol does everything it can to keep this from happening. Anything from happening. IKE IKE is really a bad design, okay? IKE was designed by two of the dumbest entities I know, U.S. governments and committees. Specifically, IKE never actually negotiates anything. It turns out that in the NSA world, if you negotiate something, you're giving out information about what you're willing to do. So you never actually want to negotiate. What you want to do is demand, I want you to do this. And if you're really kind, you'll say, I want you to do this, this, or this. And if any of those three things overlap exactly, then you win. If they don't, you just give up. That's it, right? It's really awful. So one of the things that some of us think is important in computers is studying agoric systems, systems that know how to negotiate, how to come to agreement. And it's very important for these key-like systems to be able to do this. Another problem that we're going to have to fix, matter of fact, I'm working on it right this moment because not only have the idiots taken out screwed up with X identity, but there seems to be no charge in the new systems. I want to run for you guys a test that I haven't needed to run for a long time, but it's really obvious. So now I'm trying to bring up the finger data. Finger is what I plan on using in the long run for back down direct access to keys. Okay, the problem is that then we need a keying system where you can assure the key with a web of trust-like system, which currently nothing in iPlan supports because they only trust certificates, which really isn't a web of trust sort of thing. But hear me clearly. Everyone who deals with me gets pissed on by me in email, right? If you send me an email and want to talk about FreeSwan, I want to talk to you encrypted. PGP is a piece of shit. We have to throw it out, but I use it in the meantime. And what I bug everyone is I say, if I can't finger you and get your key, what good is it? Right? I don't know which key series you're on. I don't know where your website is. You have to do that via finger. Finger is also the way that we distribute keys in the long run, but we have to build a whole new keying infrastructure with webs of trust. And the PGP guy got it.
Don't we need DNSSEC for that first?
The idea here is what he's referring to is if you can't trust DNSSEC, if, say, somebody's blocking your records, I can easily imagine some entity like a government, listen closely all you spies, some agency like a government going, man, we don't want any encrypted traffic, so they set up packet customs at their borders, and they don't let any DNS records, they don't let any key records through. So that maybe I can get a key, maybe when I'm in London and I'm trying to talk to Niels in Amsterdam, I can get keys going in both directions. But when I go back to the US of A, the keys will only go in one direction and none. At that point, we have to have a fallback system. And that fallback system, believe it or not, is going to be finger. There's no reason for it not to be. It does what we need it to do. Okay. In the meantime, if you don't get keys going both directions, you're screwed. Take heed. This is really bad protocol design. Right? Most of the time, it's really impossible to administer FreeSwan unless one person controls both ends. Because IPsec is lacking something I call DFA, Design for Administration. Right? There's no way to tell when things are going wrong. There's no way to back down to direct communication that only relies on the two hosts. All that stuff has to go in there. I'm hoping I can work on this long enough to do that. You've heard way more from me than you needed to on this subject. But we'll get the demo going. Back to John.
Finger wave.
He's a hard man to follow.
Okay, I'll walk in little tiny steps.
Sorry?
Question.
Will there be, or do you think there will be the possibility to build some little tools that the end user can see whether the actual channel he is using or gets initiated will be encrypted or not?
The question is, are there some sort of tools the end user can use to figure out whether their connection is encrypted? It's a lovely idea. The question is, what happens when those tools lie to you?
But I mean, the other way, I would say that it's a possibility to look at the log files from my gateway or my own server. So at least it would be a little bit more useful if I could have a way to go to the IPsec stack or somewhere to see the actual space.
Well, if your host is the one doing the IPsec, then you have a better chance of asking either the kernel or the daemon on your host or something like that, whether or not it thinks it's encrypting your traffic. If you're talking over an unsecure network to your security gateway, because it's securing things from there on out, and your network inside is insecure, then somebody else who's broken into your network could be telling you, oh yeah, your connection is really secure, really secure. The way we tell is we run a third machine that sits in the middle between the two guys who claim to be talking encrypted, and we run TCP down. And if we can see the plain text, then we know it's not encrypted.
Which is literally what I'm trying to get working. It'd be nice if finger worked again too.
Question?
IP6, everything is supposed to be encrypted, transparent, before everything else. What is the difference between IP version 6 and then something that technology is changed? That's not I get out.
Okay. So, question is, IPsec is supposed to be transparent, encryption, etc., lets any kind of traffic through. What's happening different in IP version 6?
Yeah, because what I've read, it is supposed to solve the problem.
Oh, okay. So what he read is IP6 is supposed to solve all the problems of IP4. Well, the answer is the difference between IP version 4 and 6 with respect to IPsec is that in IP version 4, IPsec is an optional feature. You can claim compliance with IP version 4 without ever running IPsec. In IP version 6, it's a required feature. The theory was to basically say you can't claim to be running an IP version 6, selling IP version 6 compatible equipment unless it can run IPsec. Because the people on the Internet Architecture Board realized that running the whole network in clear is a really stupid idea. And they wanted to make it mandatory that not necessarily that you had to run encrypted, but that if the other guy asks you to run encrypted, you will. So what's really happening, the difference between IP version 4 and 6 with respect to IPsec is we're debugging it in version 4, and the same packet formats and the same negotiation protocols also work in IP version 6. There are some folks who have been working with us on the FreeSWAN Linux code to make it run with IP version 6. That involves a fair bit of changes all throughout, because you have to parse IP addresses differently, pass them in and out of the kernel differently, and then the low-level packet processing is all different, etc. But we have gotten most of that stuff done and integrated. Actually, do you know the state of that, Richard?
Yeah, it's sitting in the patch waiting to be kept in. Once I review it to find out where the hell it fits.
This is Richard Briggs. He's one of the programmers on the FreeSWAN project, works on the kernel end of things from Ottawa, Canada.
Free world.
Great. We're doing all of this work in countries where it is clearly legal to export encryption software. In the United States, after a 10-year battle, we got them to change the regulations to say that we can export encryption after we tell them that we're doing it. But they managed, throughout the court cases, to retain the flexibility to change those regulations back anytime they want. And our concern is the next time somebody blows up a federal building or otherwise annoys the U.S. government sufficiently, they'll try and slap those regulations back on, and it will be another 10 years battle to get them off again. And we'd like our code to continue to be available. So there are no programmers in the United States working on this code. Hugh and I live in the United States, and I finance it, and he manages it. But all the technical work is done outside the U.S. so that it can be freely distributed to all of you and to all of us. And thank you, by the way, for keeping the rest of the world safe for encryption, or at least most of the rest of the world. Whether we could do the same for intellectual property protection. Okay, so a bit earlier I was talking about the fax effect. And the whole effect here is, once you've gotten past the early adopter stage, what's the advantage for somebody to run IPsec? We clearly have sort of a nexus of early adopters right over here. But what will get the rest of you guys to run it? And the answer is that first we'll have worked out the early problems that made it hard to install, hard to configure, buggy, and take your system down. And second, that there'll be somebody else to talk to. The way VPNs are configured, you have to actually negotiate with the other guy to set up a link. The way opportunistic encryption is configured, you set up your own end and you automatically encrypt everyone else on the other end. So the more, every time one person adds another node, it's an incentive for the next person to add a node. And that makes a positive trend in the world to move the whole network. What I call from a VPN, a virtual private network, to an RPN, a real private network. Yes.
I'm working for an ISP, and what 90% of our users is Windows users, and they don't understand what the encryptions do. But how do we make them understand it? Very easy.
So,
Yeah, but 90% are Windows users. They're not used to technology.
right, so question is, he works at an ISP, 90% of his users are Windows users who don't understand encryption. How to get beyond that problem? There exist IPsec implementations. Well, one thing you could do as an ISP is install a security gateway at the ISP, such that all of your customers' traffic goes in the clear up to your gateway, but then it goes out across the internet protected by IPsec. That would certainly be better than nothing. For the people who, there are compatible implementations of IPsec for Windows. And the one run by SSH is known to be compatible. It has a few glitches in how it operates, but it's known to be compatible. PGPNet is known to be compatible. It also has a few glitches. But we're in active discussion with those guys working that stuff out. Yeah. So Windows 2000 comes with IPsec in it, and it can be configured to do opportunistic. So does it do opportunistic using a compatible protocol to ours? Right. Okay. So, yeah, we're actually looking for people who are running the Windows IPsec to do interoperability testing with us and work out any issues there, because it's clear a lot of people are going to run that sort of thing. We're dealing with Cisco and several other vendors to try to, we actually have written an internet draft RFC for the opportunistic protocol for extension to IKE, and we're hoping to get it widely adopted on all platforms. We started off with Linux because it's free and we could go in and work on it, and it's got legs. It's moving in the world. It's getting more popular. So, why don't we turn this over to Hugh?
We've just been given leave to run over. But we actually have at least 30 minutes if we wish to use it. And if we can con these suckers into staying. Okay, hi guys, gals, and weirdos, and whatever else is out there. I'm Hugh Daniel, just in case you didn't figure this out. And what I'm going to do is I'm going to give a little more hands-on description of what we've been doing and what's going on. What you're looking at here isn't the system as it's currently set up. It's kind of the system as we plan it and hope it to be. Okay. I'm going to talk loud because even with my voice fucked up by all you smokers, I can still yell pretty loudly. This is a design diagram done by one of our users for discussions about how to rewire things in the future, but it also happens to be a pretty diagram that's about the correct thing for what we do today. What I'm going to show you is I'm going to show you opportunistic in use, up and running, so that you can see how it works and get a feel for it. My test setups tend to consist of 5 machines. East and west are security gateways, and that's where the crypto happens. They're router boxes, they're Linux boxes with 2 Ethernet on them, well, or more in my case. Sunset is the network behind, in my case it's the same machine. It's what's behind the west gateway, and east is behind Sunrise is behind east. There's also a machine in the middle that I happen to call Sky. The sunrise is sets under the sky, right? And Sky is what I use to simulate the big bad internet and to watch what's going on. Okay. So what I built here is I built a 5-machine emulation of the internet. The idea in the long run is that we want FreeSWAN or something like it running opportunistic on every device on the internet. If it's got IP in a decade, I want to see it running opportunistic IPsec or whatever's better that comes after that. In the meantime, a lot of you work for idiot organizations that aren't going to replace all their Windows boxes with Linux boxes, right? And actually, if you come to my 3 o'clock talk about software quality, you'll know why. So the idea is that in the meantime, you can buy a cheap Linux PC and set it in front of, behind, next to, in place of your router, your firewall, whatever the device is that takes your internal subnet of your school or corporation at home and gateways it to the big bad wild internet here. So that's what east and west are. Let's ignore everything on the inside here because, as I said, that's design stuff in the future. These are multiple links for failover, which we're trying to make work better. It doesn't really matter a whole lot. What I'm going to do is I've got windows on Sunset and Sunrise and on East and West. And I'm going to first do a couple of things in the clear so that you see how to see things in the clear. I will then show you the config files for what has to be done to get opportunistic going. And then we'll actually run an opportunistic connection so you can get a feel for how long it takes. Please ask questions. More importantly, ask me and John the questions down. We are citizen slave units of our Lord King Bush II. No, this is serious, okay? I can talk to you in this forum because this is a public forum, according to my lords in Washington. When I'm in private, they control my speech. Ask here, don't ask me in the hallway. That's sick. That's part of what we're trying to fight. All right, let's go on. I don't know how many of these windows you'll be able to read, but we'll live, okay? Every window is labeled appropriately, hopefully. The big window on top here is on Sunrise, and it's going to be talking to Sunset at some point. The 2 windows clipped in the upper corner are East and West control windows. I'll tell you what I'm doing. Sorry that it's not very readable, but life's rough. Let's see, the 2 little windows, let me wave cursors here, maybe that'll be better. These 2 little windows are control windows on Sunrise and Sunset. This is another window that happens to be on Sunrise that's big enough for you to read. The log east and log west are tails of various pertinent log information. If you watch those windows, you'll see FreeSWAN reporting that started up and shut down, useful things like that. The 2 windows that are somewhat readable are TCP dump windows, so that you can watch what's actually going on in the wire. Those 2 windows are on Sky, which is my internet simulator. So the first thing we'll do is we'll start up a TCP dump in this window here, okay? And this is just looking at raw packets so that we have a clue what's going on. And it's clicked on the left. You're bright enough, you figure this out. This window is much more interesting, and unfortunately, John, if X weren't a disaster, come to my 3 p.m. talk and I'll piss on people about this. That's my software quality talk, okay? Let me get this command to where you can see it without it being an issue. There. That's a really cool command. Okay? Because what this command does is it's TCP dump out the raw text, ignore my SSH tunnel, and put it on the screen in a way that won't crash your screen. Okay? Somebody asked, how do you figure out if this stuff is working or not? Okay? In the end, at least the very first time you set up IPsec, until you really think you know what you're doing, you can screw up grandly. You want to run this command or something similar. Until your eyes can see the packets and see that they've changed from clear text to gobbledygook, do not believe that you're running encrypted. Okay, this is kind of serious quality control. Be paranoid.
Actually, I heard a talk at Crypto a few years ago by Robert Morris Sr., the chief scientist of NSA, who was the father of the guy who wrote the original internet worm. He said, making rules for cryptanalysis, the very first rule is look for plain text. That is, the most common way for crypto systems to fail is by not being in the circuit at all.
Okay, and that's what we're working on here. You know, my apologies, I haven't done a particular set of tests that I haven't used CharGen or Finger in a very long time, because I don't need it. I'm experienced. Unfortunately for you, that's a pain because it's hard to see plain text in raw internet communications. I've always suggested using CharGen. The children at Red Hat have removed it. They've also broken Finger fundamentally. So what we're going to do is we're going to run a telnet session, open a telnet session on sunrise going to sunset, right? And that will go over the link. Okay? And if you look closely, here it is. Send mail, August 11th. Okay, that's your clear text. Okay, and there's the packets up there somewhere. Okay, so that's what it looks like when it fails. All right, let's oops, I have to close this. Good. Okay. Hey, there we go. Okay, so that's what it takes to do, or to get an idea of what clear text looks like. We'll get it in a moment. Again, let me make this big enough for you poor people who have to deal with it. Hello? Hey, a menu came. Mind you, this was one click under extern. Okay, is that? And I can just move that window, that one where it goes. Okay, you can see that. So, you go to www.freeswan.org, you suck down the tar file, which has everything possible that we can imagine except the website itself. All right? It has instructions for going off and compiling a new kernel. There's a lot of whining and moaning, but I expect no one in this room should be able to whine about not compiling a kernel or having their girlfriend or boyfriend sitting next to them be able to teach them how to do it. So no comments on that.
Yeah, the issue here with compiling kernel is typically the easy part. When you run as an ISP for a couple of machines, and the best way to do it was like creating a kernel package, and then there's IPsec, that's just one more patch, and there are all the other patches that you want to do.
Yeah, okay.
If you make a kernel package, then this gets kind of messy with all the patches, which
Right, and it's even going to get worse because there is no mechanism in Linux space that will patch the kernel and user space in a same way simultaneously. Right, and I have to add applications, I have to add config files, I've got to fool with the kernel, I got to do a lot of stuff. Okay, my apologies, we are working on a module install. At this point, I'm going to say something really nasty, and that is, I'm personally looking at dumping Red Hat. The reason I'm looking at dumping Red Hat for my machines is that Red Hat's had 4 or 5 years where you sat down and talked to them about what it takes to get good, solid crypto into their distributions. They haven't done it. Suzy and Connectivity have both done it. And maybe I have to learn Portuguese or German, but I'm looking at moving my laptop in the next month or two over to a distribution that has this stuff built in. And the cool thing is, once it's built in, right, once the applications are there, modifying the kernel is not a big deal, okay? We are looking at doing a kernel install, but Linux doesn't make it simple, and the guy who unfortunately is tasked with that is kind of an old mainstream Unix guy, and so it gets confused. Red Hat actually is looking to hire someone, they've got someone in mind to work on the packaging issue, but they also want to do nightmares like make all the config files as XML, which shows that Red Hat does not understand what Unix is all about. That's my software quality talk. Let's not worry about that. Okay, so you go and you follow the instructions in install. There's a separate set of instructions in our install documentation about how to do opportunistic, but really it doesn't amount to much. When you install, it creates a key for you, all right? And you can use that key. You have to add, currently you have to add, in the future these will be default, 2 configurations. Okay, configuration, a con in our language, is simply stating that I want to communicate with someone in some way. It's how you create VPN circuits. The 2 that I just highlighted are connections saying us to anyone, so us is my subnet to anyone in the world, and me to anyone is me to anyone in the world. I'll describe each line here. Auto equals route simply means bring this up and start using it. It's route instead of add for those of you in the know, because add implies that immediately there should be a SA built, and route means put this in the routing mechanism so you can build SAs as the opportunity shows up. Here we defined a subnet that we're willing to open encryptions for. This simply defines our own IP address so that we know that this is intended for us. And the other end of the connection is simply opportunistic. We don't know who it's going to be. We're going to use the opportunistic mechanisms to create it. You'll notice that me to anyone is exactly the same, except it doesn't have the left subnet. Okay. These are currently shipping commented out, or something like these is currently shipping commented out in the config files. Probably in the next thread, they will be default. Okay. The next thing you need to do is you need to take the key that's automatically generated for you and get a public version of it to put in your DNS. For cut and paste simplicity, we have the command ipsec show host hello net show host key. All right, if we just type that in, it spits out a key record. Well, it turns out key records aren't what we're using much anymore, so we say txt and 10.10.10.10 and we'll figure it out. Okay. Much better. Okay. So, what this command is saying is ipsec is our general administration command. Show host key is take the current #1 key on the system, identity key, that's hidden away in a file called ipsec.secrets, and show us the public version of it. All right. In this case, we want a TXT record, which is a type of DNS record, which we're using temporarily until we get this figured out and standards built. And what I'm doing here is I'm claiming that the security gateway for this machine is 10.10.10. That should be my own IP address. My apologies for not doing it and slowing me down. So now what I can do is I can take this data here that I'm now highlighting, and I can cut and paste that into DNS. Why don't we show you a case of this? Okay, what you're looking at here is live fire. Okay, that's a little better. This is obviously the internal DNS records for one of my home networks. It's the reverse network. At the moment, with the current opportunistic, you have to control your reverse. There's a simple reason for this. This whole design is based on IP addresses. And often all a security gateway or a host that's not violating various layer things in the OSI model, it will never see anything but an IP address. So we have to base this on IP addresses. We have ideas on how to transcend that. We'll work on them. You'll hear from us when it gets out there. Okay. So here's an example of me putting keying data into the net. If I highlight 160 through 167, okay, that's a subnet on my net. God, that's almost unreadable. My apologies. So what it says here is this is the reverse records. Mostly it's PIDR records, reverse pointer records, so you can find the forward records. What I've done is I've gone through and I've taken that same key record that I got by saying show host key, and I pasted it into DNS, saying for each of these addresses, there's a reverse for 165, and it's the PIDR record, and then there's a reverse text record, which has in it, what's this called? This is a priority of machines. You can have more than one security gateway, and this lets you have a priority, just like in an MX record for mail exchange. Then we have the host gateway. What this is saying is, for this machine, this gateway is the thing that does IPsec for me. It might be my own address, it might be the security gateway. And then we have the key. Right? I can use that key to set up the negotiations, the identity negotiations. Eventually, all that data goes into DNSSEC and is authenticated, and then we have some really nice secure communications. All right, if I do that, put in the text record for both hosts, I can now go off and do this. Here's where things get fun. And fucking start from scratch. IPsec, set up, start. Thank you. That's my own fumble. Okay, we'll do it up there. So now we've got IPsec running on 2 hosts. Okay? And you can see by looking at the log files that things happen and it's got going. Yay.
Yep.
Oh, shit. How are we doing on our time?
Can you?
We got loads. Okay.
Until the next speaker,
stopped?
you're
Yeah.
Okay, this is dry.